Bum 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 bum.
Tomatoes?
Hello, welcome to the video for what is Move Component 2. Let's run our quick little example. In the background, we can see a little tree, and it's basically moving from the right to the left. Now what this is actually doing is I have an actor that has 3 items in it. We have our root point, a cube, and our tree. These are all components, static mesh components to be exact, on an actor, and I'm moving just one component over a certain amount of time to a certain destination. So that is what our Move Component 2 node does. So let's go ahead and get started and look at it. If we right click and do Move Component and spell it properly, we'll find the Move Component 2 node under Components. And this is what we get by default. Now note it has this clock icon. That means it's basically going to be a synchronous latent action. It's going to involve a delay. Basically once it gets to this point, something's going to happen. And this node right here will not fire until this is done, but it will go ahead and let other actions inside of our program continue running. It's not going to block process. Now we have 3 input execute wires and 1 output execute, and then a few input nodes. We have a component node, some locations and rotations, some easing, and how long we want it to take. And by default, you're going to find basically you have these settings. Let me go ahead and delete our existing one and wire up a new one so we can check it out. Now what I'm doing here is pretty simple. When I start play, I'm calling my move to end event, so that way we can keep things organized down here. So move to end is basically going to call a move. Now when you call the move, it's going to take the existing location. In my case, my tree mesh has a location of 200 on the Y and 0 on each one, and then move it to wherever you tell it to. Relative. Now that is the key. It is a relative component move. So this is 200 over. So if I tell it to go negative 200 in the Y, it's going to go ahead and move over. It's going to move relative to... Here, let's show it like this. This makes it easier. We have our default scene root here. And inside of our map, this is where our scene is at. If we were to click on this, we'll find here's our root right here. No matter where this is in the scene, this item is relative to the root, and this item is relative to the root. Everything is relative to the root. That's what counts. So if I was to say, for example, move this to 0, 0, 0, you'll find it's in the middle. If I move back to 200, it's here, and it's all going to be relative to the root. So if I wanted it to go to the middle of my world, unfortunately I can't just say go to 0 because that's going to be world relative and not relative to my local root. So keep that in mind. So let's say I wanted this to go to the middle of my actor, then I'll use 0. And let's say I want it rotated, let's say 90 degrees on the Z, you'd set the target relative rotation. And if we run it, you'll notice, assuming I set it up properly, it'll start moving. And you'll notice it's not moving properly. Well, that's pretty simple. Unfortunately, it's not going to error out, but you're going to have to plug in what you want to move. And it's going to require a scene component reference. Now, a scene component reference is this right here. This is our default scene root. But it's also going to be other items. Most other items that you're going to add components in here, for example, a scene or skeletal mesh, static mesh, cube, sphere, things like this, they're going to contain their own scene root because the scene root component is basically what gives you your transform, your location in the world. So most of your items you're going to be able to go ahead and move. So it's not an issue. You're basically going to want to drag in your component, in this case my tree mesh, and drop it in. And now I'm saying, okay, when we run this, move the component to this location and this rotation over 0.2 seconds. That's our overtime. Hit play, and you'll notice it pretty much snaps into place. We'll adjust our time to something more appropriate, like 3 seconds, and hit play. And you'll notice it now moves over 3 seconds from where it is currently to the new relative location, which is 0. Let's bump this up to 5 for our next example. So, as you noticed, when it went, it started moving the rotation, and it rotated around the Z 90 degrees. Now, it's really hard to tell because the Z is a silly choice for me to choose. So if we went to do something more like 90 on the Y and hit play, you'll notice it's now rotating on the Y. That's pretty simple. Now our two eases are our basic eases, whether we're going to ease on the out or the ease on the in. Out is when it starts, in is when it stops. So if we ease on the out and hit play, it'll slowly move and ramp up to full speed, and there we go. If we do an ease on the in, it'll slowly move, ramp to full speed, and then slow down and stop again. If we do this over maybe 7 seconds, might be a little easier. We'll see a slow, goes to full speed, and then slows back down when it gets to destination. And that's what our easing is going to do. Now the other input execute wires are a little bit more interesting. Let's hook up our completed, and we'll hit play, and you'll notice when this finishes, on the top left, we're going to get a string that says finished. Nope, it says done. Apparently I wrote done. And that just means, let's make this a little longer. When this node finishes its movement to this location, completed is going to fire. Now one thing to keep in mind here is we have our stop and our return. These wires are only valid until this node is completed. And that's important to note. If I go ahead and wire up a return node here, let me do this. And I've wired up a return node. I'm going to wire up another node up here, a timer, and simply tell it to, let's see, what do we have it called? Return to start. Let's name it properly. Return to start. I tell it to return to start, and I tell it to return after 3 seconds. We'll go ahead and hit play, and you'll notice the node moves. After 3 seconds, it'll now return, and when it gets to the original point, it says done. If I was to wire this up to return after it was completed, let's go ahead and not call this anymore. So now we're going to move to end. When it's completed, print the string, and then return to start. And return to start is just going to call it return. We'll run that again. You'll notice it's going to say done. And then nothing's going to happen. Now technically something is happening. It is actually running our node again. The issue here is, if we were to run this again, and whoops, move this quickly and watch what happens. Our move finishes, and you'll notice the return to start executes. We tell it now to return to our new location, which is going to be our 0 location, and then we'll print out the string done. Unless this node is in progress, we cannot stop it or return it. That is because it does not retain the information between runs of this node. This node is only good for information until it hits completed. So in this case, if we do stop moving right here, and we tell it to run after 3, we'll see what happens. Well, you notice it's going to continue. I didn't wire up stop. Wire up stop and hit play. After 3 seconds, I probably named something wrong. What did I name wrong? Actually, I didn't name anything wrong. This is funny. It's actually running properly. So what's happening here is, let's unhook this right here and hit play. This is one of those things where this is a funny node. Let's okay, I don't think I'm calling, hook up, stop moving, try that again. And there we go. You'll notice it says done at the top left. Stop moving will stop the move component immediately and fire off a completed. So that's another thing to keep in mind. So if you want something to move, pause for a little bit and then return. You can't really use this for the most part. It's going to stop, fire off the done, and then any information saved in here is going to be gone. That's pretty much going to wrap up our move component 2 node. You could do this stuff in other things. You could use a timeline, you could use some lerps, you can use some move actor components, have them relative. It's a bunch of other nodes that this basically condenses into one. And it's useful if you have to move a component as part of another actor, in terms of, you're basically moving parts of an actor. This blueprint here, you're moving parts of it. The move component node is for that.